This is your Daily 10, Calculator, Video 1. Make sure you pause the video and attempt the questions before you watch the solution. Here's your first question. So here all we need to do is find the midpoint between two coordinates. Well, in order to do that, we need to find the midpoint of the two x coordinates, so what's halfway between 2 and 8, and also the midpoint, so halfway between 12 and 2. The little rule that we've got is if you add the two numbers together and half it, that will tell you the midpoint. So here, 2 add 8 is 10, half it is 5, so the first part of the coordinate needs to be 5. And same for the second number, 12 add 2 is 14, half that is 7, so we need the coordinate 5, 7, which is here. Here's your second question. So for this question, to find the product of prime factors, the first thing we need to do is use a little factor tree. There are other methods, but a lot of people do like using this one. So I need two numbers that multiply together to make 280. So I'm going to keep it quite simple, and each time when I can, just split it into 2 and that number, so I can just start halving. Now 2 is a prime number, I can't split that, so I'm going to stop with that one. 140, however, I can split, so I'm going to keep it nice and easy and do 2 and 70. 2 is prime. 70 isn't though, that can be split into 2 and 35. Again, 2 is prime, so we can stop there. 35, that's the product of 5 and 7. 5 is prime, it can't be split down. Neither can 7. So at that point, we've found all of the prime factors. To write it as a product of prime factors, we then have to write each of the numbers at the end of the branches, the ones that I've circled, with multiplication in between, because it wants the product, which means times, of each of the prime factors. Now with this only being a 2-mark question, this would be acceptable. If it had been a 3-mark question, or if it had mentioned anything about being in its simplest form or in index notation, we would have had to write 2 to the power 3, 2 times 2 times 2, times 5 times 7. If I write this here, this is also acceptable for the 2-mark question. Here's your next question. Now this is the first one where we're going to need a calculator, so we'll bring that one in because I think we might need it for this question. So here we're being asked to find the area of this parallelogram. Well, normally the area of a parallelogram is base times height. However, we don't have that information here. What we've got is the base of the parallelogram and this slanted side here. What does jump out though is the fact that we've got these two sides here and the angle in between. Now there's an area of maths at that point that I'm trying to remember that comes up and has something to do with area where we've got two sides and the angle in between. At that point I'm starting to think there is a trig rule that works out areas of triangles, so this area here, using these bits of information. That formula that we need for this is the sine rule. So we've got the area is equal to half AB sin C, where A and B are two sides and C, the angle here, is the angle in between those two. So if we use the information we've got here, that tells us we need to do half times 12 times 16 times sin 72. So if we type that into the calculator, we're going to do half times 12 times 16 times sin of 72. That gives us an answer, if we round it, to 91, and because I'm going to use this number a little bit later, I'm going to round it to a few decimal places there. Now that's good because that's worked out the area of this section. Here we've got an extra little property that you might need to know. If you split a parallelogram like this, we've effectively split that parallelogram in half. So this area here is exactly the same as this area up here. So all I would now need to do is take the area that I had before and double it. So times my answer by 2. And this gives us 182.6 centimetres squared, which is given us already on the paper. Here's your final question on this video, a vector question. So for this question, it's wanting us to find what vector would describe D down here to E over here. Now I always view vectors as trying to get around a map where we can only use certain streets. We can only use streets that have got a vector actually put on. Now if we read the information up at the top, AFE is a straight line. It's going to be telling us that because we're going to use that information. Next line down then says AF, so this section here, to FE, this little bit here, is in the ratio 3 to 2. So what we could do with that, we can either use fractions or we could use a bit of diagram work, is we can say, well, if this is 3 parts of the line, so let's split that actually into 3 sections, this bit down here is 2 parts of the line. So actually let's split that into 2 sections. We'll just make sure we can see the arrow because I think we might need it. Well, if this section down here is 2 parts of the line, and A is all of this, each little section, each little chunk here must actually be half of A. That therefore means if each of these is half of A, this bit here must be half of A, so is this, and so is this. Now if you notice the arrow was pointing up, so all of these are going in this direction from E up to A. The next line down says that DE is parallel to CF. Now that tells us that these two, CF and DE, they are multiples of each other. That's what parallel means within vector questions. And then for the final section, it's telling us that DE, the line we're trying to find, is 2 CF, so it's double the length of this. So if I'm trying to find the line down here at the bottom, in my mind, the best thing I can do is find the vector that describes going from C to F, and then just double it for D to E. So let's have a go at that. To get from C to F, I would need to go from C up to B, so at that point we've got 3C. I'm going then from B to A. Now that means I'm going backwards, I'm going against this arrow, so that would give me minus 2B. I'm then going from A down to F. Now that's half, 1, 1.5 lots of A that I'm doing there. And if you remember before, I put this little arrow back on, we're going backwards against the arrow, going the wrong direction, so it's minus. So this here is C to F. We want double the length of that because we've saw at the top of the question just here that DE is 2 lots of CF. So if we just times all this by 2 now, we get 6C minus 4B. Well, 1.5, double that, times that by 2, gives us 3A, and there is how we would get from D to E.